are highlighting and unhighlighting and are touched. And it's my pleasure to share the game project. The system can help you this section. Hopefully most of it. Welcome. So the previous section was very much review for you. Hopefully most, if not all the things we did are things you're already familiar with. From this point on in the course, most of the things we'll be doing will most likely be completely new to you, not least of which is the gameplay ability system. In this video, we'll discuss what the gameplay ability system is and how we'll use it for the game project. The game we'll be developing throughout this course was designed to teach you all of the main features of the gameplay ability system and how to apply them in various ways. So what is the gameplay ability system? Well, according to Unreal Engine documentation, the gameplay ability system is a highly flexible framework for building the types of abilities and attributes that you might find in an RPG or MOBA title. You can build actions or passive abilities for the characters in your games to use, and status effects that can build up or wear down various attributes as a result of these actions. Additionally, you can implement cooldown timers or resource costs to regulate the usage of these actions, change the level of the ability and its effects at each level, activate particles, sound effects, and more. The gameplay ability system can help you to design, implement, and efficiently network in-game abilities from as simple as jumping to as complex as your favorite character's ability set in any modern RPG or MOBA title. Now, that all sounds pretty good, but it's also kind of a little vague, and that's because the ability system is so vast and capable that it's almost impossible to condense down into a single paragraph like this. So we're going to talk a little bit more about what the gameplay ability system is at a high level before we get started creating the various components of the system in our game project. So now that we've seen the documentation's definition, let's actually talk a little bit about what GAS is. Well, let's say you have the goal to create a video game. Now, there are many different game genres, so for the sake of this discussion, we'll just say that your plan is to create an RPG. An RPG, or role-playing game, is typically a fairly large game project involving a number of elements, including attributes, commonly referred to as stats, and these are values that affect gameplay in significant ways. Examples of attributes include a form of health or life for the character that the player will control throughout the game. Life is typically defined as the amount of damage the character can take before being killed or eliminated. Damage itself is often treated as an attribute and can be affected by a number of factors, including the character's other attributes, equipment such as armor and weapons, and the effects of magical spells, or anything else that you decide. Now, other attributes are typically defined to affect various aspects of gameplay. Attribute values may even depend on other attributes. As one attribute changes, other attributes that are derived from it often change according to some mathematical formula determined by the game's designers. For example, the character may have a critical hit chance attribute called crit. And this critical hit chance adds the chance to cause bonus damage when the character attacks. Now, this crit chance may be derived from a combination of other attributes. Let's say the character has a resilience attribute, RES here on the x-axis of this graph, and when resilience increases, critical hit chance also increases by a certain amount. RPGs often have a large number of attributes that affect various aspects of gameplay. Now, attributes aren't the only feature of a game. We mentioned damage and the act of causing and taking damage. Well, damage is typically caused by abilities. The character may attack other creatures or players in the game, and attacking involves several actions that act in unison with each other. Attacking typically involves playing some sort of attack animation, whether it be a sword swing or a spear thrust or casting a magical spell. The attack typically involves hitting the target and causing damage to that target. Causing damage in an RPG means checking the values of attributes, both on the attacker and the target, and performing a series of mathematical calculations that take these attributes into account before determining the final amount of damage caused. If the damage caused to a player or creature is fatal, meaning that it's brought the target's health or life attribute down to 0, the target may die. In RPGs, this is usually accompanied by a reward of some sort. The reward often issued in RPGs comes in the form of experience points, or XP. A character can accumulate experience, and once this character has amassed a certain amount, determined by a threshold for that particular level, that character may reach a point where it's now eligible for an upgrade of some sort. We often call this upgrade a level up, where the character's level, a numerical value designed to be a measure of cumulative progress in the game, goes up. Now, leveling up is often accompanied by an increase in the character's overall power in the game, such as an increase in attribute values or even being granted newer and more powerful abilities. By leveling up, the character has become capable of taking on even stronger enemies, causing more damage, and earning even more valuable rewards. Speaking of rewards, there are often gameplay mechanics in RPGs that result in strengthening or weakening the player. Mechanics that strengthen the player are often referred to as buffs, and mechanics that weaken the player are often referred to as debuffs. Drinking some sort of potion may increase the player's health or mana or some other attribute. Casting a spell may temporarily increase some of the player's attributes or decrease attributes on the target. Buffs and debuffs can be applied as a result of picking up or consuming items, or they may be applied as a result of being hit by certain abilities or receiving damage of a certain type. So effects are some sort of gameplay mechanics that result in changing attribute values, and the reasons and situations involved depend entirely on the game's design. Now, we've discussed a lot of mathematics thus far. Attributes have their own numerical values, and effects caused by elements in the game often change these values, but there's often some sort of visual or audio cue associated with any given gameplay mechanic. A sword hitting an enemy releases a splash of blood on contact. That's usually some kind of particle system. A magical fireball explodes on contact, which creates a loud boom sound. These visual and audio cues are every bit as important as the underlying mathematical calculations that affect the various attributes in the game. Now, we've described many features that you see in RPGs, but these are commonly used in many other game genres. Shooter games make use of attributes such as health and stamina. Just about most games involve some sort of health or life, and nearly all games make use of a form of progress, even if it's not called the player's level. The point is that games can get quite complex, and the more complex a game becomes, the more relationships the various game elements have with one another, and the more difficult it can be to manage all of these relationships. It can help if there is a system that allows us to organize these relationships, these attributes, effects, abilities, and gameplay cues. That's where the gameplay ability system comes in. Now, can you make a complex game, these attributes, effects, that allows us to organize these relationships, these attributes, effects, abilities, and gameplay cues? That's where the gameplay ability system comes in. Now, can you make a complex game such as an RPG, similar to what we just described, without the gameplay ability system? Well, of course you can. Countless games, even super complex RPGs, have been created before the gameplay ability system was even invented. But those games, at least the ones successful enough for you to have heard about them, succeeded as a result of impeccable design, management, and code framework. The gameplay ability system provides us with such a framework. The gameplay ability system was designed to handle the complexities of the game Paragon. Paragon was a multiplayer online battle arena, or MOBA, developed by Epic Games. A MOBA is a competitive multiplayer game involving multiple character types. Each character type generally has its own set of unique abilities and strengths. Characters in MOBAs often gain experience, level up, and earn new abilities all in the space of a single multiplayer match. It's a game genre that combines just about every technical challenge a game development team can face, and all of the complexities that we've discussed thus far are generally implemented in MOBAs. It's the type of game project that absolutely requires a solid framework that is modular, flexible, and scalable. It must have a codebase that can accommodate for attributes, effects, abilities, and cues, and do so in a way that is handled well in multiplayer and allows for each element in the system to interact with any of the others in an efficient and well-coded manner. To handle such a complex system, Epic Games created the gameplay ability system. Sadly, Paragon was eventually canceled, and Epic decided to focus its game development efforts primarily on Fortnite. However, Paragon wasn't a complete waste of time, talent, and resources. It turns out that GAS, the gameplay ability system was so well structured, so versatile, and so expertly coded that it can be utilized in any number of situations. It allows a game to have a complex system of attributes, abilities, effects, and cues, and now it is an integral part of Fortnite itself. The gameplay ability system is a masterpiece in software engineering and provides a fully replicated way to handle complex gameplay mechanics. Fully replicated means it works in a networked multiplayer environment with lag compensation, providing a smooth gameplay experience even in the presence of lag. So can you make a complex game such as an RPG without gas? Well, of course you can. But learning how to use and implement gas will allow you to do so in a way that is expertly organized, easily scalable, modular, and with the efficiency good enough for a fast-paced, competitive MOBA title, saving you literally years that it would take you to engineer such a work of art. Gas is the most beautiful piece of software engineering that I've ever touched, and it's my pleasure to share my knowledge of the system with you. Unreal Engine developers who wish to expand their capabilities into a realm in which serious, complex games exist can do so with the use of gas, and seeing as how you're one of them, it's time to get started adding gas to this course project, designed to showcase and unravel the features of the gas masterpiece, one piece at a time. Let's see what forms of magic we can create. And we need to create Welcome back. So now that we have some sort of idea what the gameplay ability system is, we need to know the different parts that make up the system. So we'll discuss those in this video and lay out a plan for the next steps moving forward that we can take to start adding gas to our project. Now, one of the most important parts of gas is the ability system component. This is a type of component that can be added to an actor, and it handles lots of important things in the gameplay ability system, such as granting abilities, activating those abilities, handling notifications for when certain abilities are activated or effects are applied, and lots of other things that we'll learn about. So the ability system component is something that we must add to our character if we'd like that character to participate in gas. Now, just as important as the ability system component is the attribute set. Just about any game involves a number of attributes that you associate with any given object or character, and these range from life and mana to just about any other attribute that you can think of. In gas, we store these attributes on the attribute set, which has a number of capabilities that allow us to associate those attributes with other various parts of the gas system. Now, at the core of the gameplay ability system are the abilities. Gameplay abilities are classes that we use to encapsulate the functionality of some sort of thing that a character or object can do in the game. Things like attacks and casting spells are generally abilities, and the gameplay ability allows us to keep all the code and functionality kept inside of a specific gameplay ability class. Now, gameplay abilities run asynchronous tasks that we call ability tasks. These allow us to execute code that is asynchronous, meaning that once we start the task, it may perform its job and finish immediately, or its job may span across a period of time and may do different things depending on what's going on in the game for that specific ability. So ability tasks are like the workers that perform the work for the gameplay ability itself. Now, we also have gameplay effects. These are what we use to change the values of attributes, and they're capable of a number of different things related to attributes. We use gameplay effects to change attributes directly, change them over time, periodically increase or decrease them, and associate those attribute changes with various calculations that take other parameters and attributes into account. We also have gameplay cues. These are responsible for handling cosmetic effects, such as particle systems and sounds, and can handle the replication of those as well. Now, another core part of the ability system are gameplay tags. Now, gameplay tags are not actually unique to the gas system. They exist outside of gas and can be used in non-gameplay ability system projects, but their use is pervasive all throughout GAS, and gameplay tags are extremely useful for identifying just about anything you can think of, and their hierarchical nature makes them more versatile than simple variables such as enums, booleans, or strings, and we'll learn all about their usefulness throughout the course as we use them. So these are the main parts of GAS, and we need to start with the first two of these in order to incorporate GAS into our project. We need an ability system component and an attribute set. Now, the way that we add an ability system component can vary. We can have a pawn, and in the case of our project, our player-controlled pawn is an aura character, and you can add the ability system component directly on the pawn class. You can do the same thing with the attribute set if you like. Now, another option is to take some other class associated with your pawn, such as the player state, and add the ability system component and the attribute set to that class. Now, there are various reasons to do it one way or another, and the truth is, you have some flexibility here. But let's discuss a couple of reasons to put the ability system component and attribute set on the pawn versus the player state, specifically. Let's say that we've added our ability system component and attribute set to the pawn class. And let's say this is a multiplayer game, at which point our pawn dies, and we decide to destroy that pawn so that we can respawn another one. Well, because the ability system component and the attribute set exist on that pawn, when the pawn is destroyed, so are the ability system component and attribute set. They go away. And if you haven't taken measures to save any pertinent data on those classes, say in a save game object or on a database somewhere, that data is gone, and when you respawn a new pawn, the ability system component and the attribute set are created fresh, starting off at their default values and with the default abilities. Now, let's say instead we have the ability system component and the attribute set on the player state, which is associated with our pawn. Now, if our pawn dies and we destroy it, the ability system component and the attribute set don't get destroyed with it, because they don't exist on that class. They exist on the player state, which persists when you destroy the pawn. So we can spawn a new pawn and associate it with our player state, and then we still have the same values in our attribute set and the same abilities in our ability system component because they haven't been destroyed. Now, this is one reason to set things up this way, but another reason is you just might not want your ability system component and attribute set cluttering up the character. You may wish to swap out your character for another character, and you may not want your ability system component and attribute set to be unique to any given character. You may want to keep that associated with the player itself. Now, reasons to keep these things on the pawn may be that the pawn might be simple. Your game might have simple enemies that do have the ability system component and attribute set, but there's no need for a player state for those enemies because they're simple. They just have to have attributes and abilities and perform their logic based on AI, so an ability system component and attribute set directly on the pawn might be appropriate for that scenario. In this game project, that's the approach we're going to take. Our enemy characters are going to have their ability system components and their attribute sets directly on the character class. But for our player-controlled character, we're going to put our ability system component and attribute set on the player state. This gives us the opportunity to see both ways of doing things and the things that you have to take into account doing it one way versus the other. So we need these three classes, and these will be associated with our player controller and our character, which we've already created. What we have not created yet are the player state, the ability system component, and the attribute set. So we have a number of steps to take to get started adding gas to our project. First, we need a player state class, and we need to create an ability system component class that we can add to the player state. And of course, we also need the attribute set. These are the fundamental classes that we're going to need to create to start implementing gas in our project. And we'll start making those next. Welcome back. In this video, we're going to create our player state class and assign that to Aura. So let's go into C++ classes Aura public, and we have the player class, which contains our player controller. I'd like to create our player state class here in this folder as well. So I'm going to make a new C++ class and find the player state base class. Here it is. Clicking next, and we'll call this Aura player state. And create class. I'm going to close out of the editor and wait for that class to appear right here in Writer. And here it is. So we have Aura player state.h and .cpp. I'm going to go ahead and close the other tabs and just have my header and CPP files open here. And I'd like to create a constructor straight away. So I'll make a public section and add an Aura player state constructor here and generate the definition for it. And I just like to set one thing here in the player state, and that's the net update frequency. I'm going to set that to 100. Now, what is the net update frequency? Well, this is how often the server will try to update clients. So as changes occur on the server for the player state, then the server will be sending updates out to all clients so that they can sync up with the server version. So any variables that should be replicated, they'll update, and the server will try to meet this net update frequency if it can. Now, normally the net update frequency is quite low for the player state, something like half a second. So if we're going to have our ability system component and our attribute set on the player state, we should set this to update faster. And in fact, in the Lyra project and games like Fortnite, where the ability system component and attribute set are on the player state, they set the net update frequency to a higher value, and that's usually about 100. Now, we'll talk more about replication throughout the course and the significance of things changing on the server versus clients and what all that means. But for now, we're just going to have this set to a value of 100. And I'm going to go ahead and compile and launch the editor so that I can make a blueprint based on Aura player state. So now the next step is for us to create a blueprint based on our new player state class. We'll right click on Aura player state, create a blueprint based on it, and we'll stick it in blueprints, and we have player, we'll stick it in that folder, and we'll call this BP underscore Aura player state. We'll create that class and So far, there's really nothing to do here in the blueprint. We're just going to go ahead and save and close it, but we do want to make sure that that is the player state we're using. So we'll go to our blueprints folder into game and open BP Aura game mode where we can set the player state class here. We're going to open the dropdown and set this to BP Aura player state and compile and save. And now we successfully have created our own custom player state class and Aura is using it. Now we haven't done anything in this class. We can press play and run around and really we won't see any difference because, well, our player state isn't really doing anything, but we know that that is where our ability system component and our attribute set are going to live for our player controlled character called Aura. And for the enemies, we know that the ability system component and attribute set are going to go on the enemy class itself, and we'll learn the different nuances and things we have to consider when doing it one way versus the other. So now what's left to do is to start creating those gameplay ability system classes, and we'll do that next. Welcome. Welcome back. Welcome back. So we're ready to start. start creating some classes. Welcome back. So we're ready to start creating some classes that belong to the Gameplay Ability System framework. Now that means we have to enable Gameplay Ability System as it's a plugin in Unreal Engine. So we have to enable that plugin first and foremost. We do so by going to Edit and Plugins and search for Gameplay Abilities. And we check the checkbox for Gameplay Abilities. Now we have to restart the editor, so we'll restart now. And with that, Gameplay Abilities are enabled. And we can start making classes in the Gameplay Ability System. The checkbox for Gameplay Abilities. Now we have to restart the editor, so we'll restart now. And with that, Gameplay Abilities are enabled. And we can start making classes in the Gameplay Ability System plugin. Now we know we want an ability system component and an attribute set. So we're going to create those. And that means we'll go to C++ classes Aura public. And I'd like to right click and make a new C++ class here. Now I have to choose all classes and search for ability system component. And here we have one. Now, clicking next, I'd like my ability system component and my attribute set to be in their own folder. So I'm going to make a new folder here called ability system. And this ability system component, I would like to be the base class for all ability system components in my project. And because my project is called Aura, I'm going to use Aura as a prefix. So many times when you look at code for a large project, you usually have some kind of prefix that goes before most of your classes that represents sort of the dev team or maybe the project name or something like that. For example, if I were creating a shipped game with my company Druid Mechanics, I might have DM here, so it might be called DM ability system component. But this project is called Aura, so I'm going to be using Aura as a prefix. As you've seen already, we have Aura player controller, Aura player state. Now we're going to have Aura ability system component. So let's go ahead and create this class. Now, before I close the editor, I'm also going to create the attribute set. So I'm going to right click, new C++ class, and I'll search for attribute set and choose attribute set. I'm also going to place this in ability system. And I'm going to call this Aura attribute set and click create class. Now I'm going to go ahead and close out of the editor and wait for writer to update. And now after collapsing some of these folders to keep this nice and neat, I'm going to expand ability system to see Aura attribute set and Aura ability system component. I'm going to go ahead and open Aura attribute set. Here's what it looks like. And we see that our attribute set is based on the class U attribute set. Let's look at Aura ability system component. We see that it is based on U ability system component. So this is looking great. So now we have these classes and we can go class, and I'll search for attribute set. attribute set. I'm also going to place this in ability system. And I'm going to call this Aura attribute set. We're creating a shipped game with my company Druid Mechanics. I might have DM here, so it might be called DM, as you've seen it. So now before I close that set, so I'm class, and I'll search for attribute set. And choose attribute set. I'm also going to place this in ability system, and I'm going to call this Aura attribute set. And click create class. Now I'm going to go ahead and close out of the editor and wait for writer to update. And now after collapsing some of these folders to keep this nice and neat, I'm going to expand ability system to see Aura attribute set and Aura ability system component. I'm going to go ahead and open Aura attribute set. Here's what it looks like. And we see that our attribute set is based on the class U attribute set. Let's look at Aura ability system component. We see that it is based on U ability system component. So this is looking great. So now we have these classes and we can go ahead and wrap up the video. But before we do so, we're going to want to include some modules that we'll be using in our code for our gameplay ability system project. So we're going to go into aura.build.cs so we can add some modules here. Now we can add these to the private dependency module names. We're going to add a few things here. One of the modules we need is gameplay abilities. There are some classes that exist in that module that we'll need because we're going to be creating that we'll need that until it's modules. Add those. We have us and now we'll learn how that works to our attribute set class, player state and class. It means to these various classes. So great job, and I will see you soon. Welcome. Now, so far, there have been a couple of times that we've thrown a couple terms around that have to do with multiplayer. So I think it's about time we start to discuss multiplayer and its relationship to the gas system. Now, in a multiplayer game, there exists a server, and in most cases, just one server. And this server is an instance of the game running separately and independently from the other machines. They're also running their own version of the game. We call those clients. Now, the server is different than the clients, and we're going to discuss those differences in this video. Now, in a multiplayer game, the server can take on a number of flavors. For instance, there's the dedicated server. A dedicated server has no human player, and no rendering to a screen occurs. It's just a computer running the game simulation. Now, because there's no human player and no actual rendering to a screen, don't let that fool you into thinking that things are not happening on the server machine, such as players running around, shooting each other in a shooter game, casting spells in a magic game, leveling up and gaining experience, and things like that. Those are all things that can and do happen on the server version of the game. They just don't happen to be showing that by rendering images to a screen, as the server doesn't need to do that. Now, aside from the dedicated server, there's another type of server model called the listen server. Now, this differs from the dedicated server in that the listen server is a human player, or at least it's a computer running a version of the game on which a human player is controlling a pawn or character. We say that that human player is hosting the game. Now, the host has an advantage in the listen server model, and that advantage is that the host has no lag. Lag is the result of the time that it takes for data to travel across the network from the server to clients and from the clients up to the server. In a listen server, the host is the server, and the server doesn't have to send data across the network to itself, so there is no lag for the hosting player. Now, in Unreal Engine, we treat the server as the authoritative version of the game. Things are happening on each machine. Players run around, they change their positions, and this happens on each and every version of the game that's running. But because of lag, your version of the character's location on your machine is going to be different than your character's location on another player's machine and on the servers. So we have to decide which machine is the correct version. We consider the server to be the correct version of the game. And for this reason, we do important things on the server. Now, what are those important things? We'll learn about those as we go along and program the game, but it's important to know that the server is always considered the authoritative version of the game. Now, if we draw a dotted line between the server and the clients, we can make some distinctions about certain game classes. The game mode exists only on the server. If you attempt to access the game mode on one of the clients, you will get a null pointer. That's because the game mode is responsible for things like rules of the game, spawning players and restarting the game, things like that. And those are some of those important things we were talking about that should only be handled on the server. Now, the player controllers for each player exist on the server, but they also exist on each client. So the server has an authoritative server version of each player controller, and each client has their own local version. But notice that client 0 only has player controller 0 on its machine. There is no player controller 1 or player controller 2. All the other players, player controllers, don't exist on client 0. It's only the server that has all of the player controllers in the game and can access them. Now, the player state is another story. The player states for each player all exist on the server, but they also all exist on each client. Client 0 has a version of player state 0 along with player state 1 and player state 2. So that's a distinction from the player controller class. Now, if that seems confusing, just think of it as a sort of similarity that the player state has with the pawn. You see, the server has all all three pawns in the game, but each client also has all three pawns in the game, which makes sense. If you're playing the game, you have to be able to see your pawn running around, but you also have to see the pawn controlled by client 1 and the pawn controlled by client 2. It only makes sense that your machine has copies of all three pawns in the game. Same with client 1. It needs to see your pawn as well as its own and client 2's. So all the pawns in the game exist on all machines. The same goes for the player state. Now the HUD and all associated widgets that get shown on the screen are sort of different than all the other classes. Each client has its own HUD class, and it only exists on that client. So if we're talking about a dedicated server, there is no HUD on the server. If it's a listen server, then the only HUD that exists is the HUD for that local player playing the game. Each client only has its own HUD and any associated widgets that get shown to the screen for that player. Client 0 does not have access to client 1's HUD. It doesn't exist on client 0's machine. So what does all this mean in relation to replication? We set our player controller class to be replicated. What does that mean? And our player state was set to have a net update frequency of 100. What does that mean? Well, net update frequency just means that as changes are made on the server, every single net update, the server sends data down to the client so they can be informed of that change. A net update frequency of 100 means that those changes will be updated on clients 100 times a second as long as the server can manage that. When data is transmitted from the server down to clients, we call that replication. And here's how it works. Let's say you have a variable on the pawn class. Now, it could be a float, an integer, or any other type. Now, it exists in the pawn class, which means that each version of the pawn has that variable. The version of the pawn on clients, the version of the pawn on the server, they all have the variable. Now, if the variable is designated to be a replicated variable, then if that variable's value changes on the server, then the next net update, that change will be sent down to all clients so that the client version of that variable can be updated to the new value. This act of sending that data down to clients is called replication. Now, what happens if we have a replicated variable and it gets changed on one of the clients? Does that mean that the server will be informed of that change? In other words, does replication work both ways? The answer is no. Replication only works one way, from server to client. So if a variable is marked as replicated, it should not be changed on clients because the server will not know about that change, and neither will any of the other clients. Only the client who changed that variable will know about it, and that variable will now be out of sync with the server's version of that value. And remember, the server is the correct version, so the variable on that client will now be considered incorrect. Now, you might be thinking, if replication only works one way, how would a client ever get data up to the server? Obviously, that has to happen sometimes, right? I mean, we make input with our keyboard and mouse or controller. That input has to make its way to the server somehow. Well, yes, it does. In the form of replicated functions, which we call RPCs, or remote procedure calls, and we'll learn about those later. But the truth is, this high-level overview of replication is just about all you need to know about multi multiplayer for this course. You can learn all about it if you take my multiplayer shooter course, but there's a reason that course is not a prerequisite for this course, and that's because most of the multiplayer stuff is handled under the hood for us in GAS. We will need to know a little bit about multiplayer, but for the most part, GAS handles a lot of stuff for us under the hood. And we'll learn about that stuff that GAS does for us so that we can appreciate and let it work for us. As we're building our game. And all of the gameplay mechanics that we implement in this course will work in multiplayer as well as single player. So now that we know a little bit about how the classes work in relation to multiplayer, we'll now move on and add our ability system component and attribute sets to our player state for our player controlled character. And to the character class for our enemies, and we'll learn how to associate the ability system component and attribute set with its owner, and we'll learn what that means in the videos to come. I'll see you soon. Welcome. Now, so far, there have been a couple of times that we've thrown a couple terms around that have to do with multiplayer. I'd like to make sure I think it's about time we start to discuss multiplayer and its relationship to the GAS system. Now, in a multiplayer game, there exists a server, and in most cases, just one server. And this server is an instance of the game running separately and independently from the other machines. They're also running their own version of the game. We call those clients. So we can create an object of type Okay, so we're ready to actually add our ability system component and attribute set to our corresponding classes that need them. Now, the first thing I'm going to do is open up my Aura character base class here. And I'd like a couple of pointers here to store the ability system component and the attribute set. That way, those pointers will be inherited by all characters, whether those characters are going to construct these in the character class or not. Now, we've already decided that we'll be constructing and owning the ability system component and attribute set on the enemy class, but for the player controlled character, those will be owned by the player state. So in this video, we're going to take care of both of those cases. But either way, Aura character base is going to have pointers to the ability system component and the attribute set. We'll keep those right here in the protected section. And if we have to move them into public later for any reason, we can. Now these will be T object pointers. So we'll make a T object pointer of type U ability system component, not the Aura version, just the engine class, and we'll call this ability system component. And we'll go ahead and make this a U property, and we'll also have a pointer to the attribute set. So we'll have a T object pointer for a U attribute set called attribute set, and this will also get a U property. Now we have two pointers. And we want to construct these, but not in Aura character base, because as we just said, we want the player controlled character to construct them in the player state. But for Aura enemy, we can construct these in the enemy's constructor. So let's go into the private character folder and open Aura enemy. And right here in the constructor, we'll go ahead and construct these. We'll say ability system component equals, and this is a component, so the way to create a component in the constructor is going to be create default subobject. And for the type, I'd like to make sure our enemy gets a U Aura ability system component. So I'm going to say U Aura ability system component, and for the native name, we'll call it ability system component. So we can create an object of type Aura ability system component and store it in our member variable, which has the type ability system component. Now I see some red squiggles, which means I might have a typo somewhere because this should be legal. So I'm going to go back to Aura character base, and sure enough, I do have a typo. I spelled component wrong. So that should fix it, and that fixes the squiggles. All right, and before we can compile, so that should fix it, and that fixes the squiggles. All right, and before we can compile, these are of course incomplete types here, which we could forward declare right up here at the top. So we'll say class the attributes will compile. We want to make sure that that ability system component is replicated. So I'm going to say ability will pass in true. Now the video we're going to, but we're also going to construct tools. We'll use that attribute set for populated in Aura character base character, which is not an enemy. These 2 points, you don't want to do it in initialized or a character state. And I'd like to have two in the player folder or a player state.h. And I'd like to have 2 pointers, just like we have in Aura character base. We want ability system component and attribute set. So I'm just going to copy these from character base and put them here in Aura player state. I'm going to give this a protected section and simply paste it in these variables, and I'd like to construct them in the Aura player state constructor. And we'll do so the same way we did in Aura enemy. So we can copy these lines where we're constructing these two, and we can paste them in Aura player state. So I'll open the CPP file. And just above setting our net update frequency, we'll go ahead and paste these, and Rider's telling me I need to include these header files for both of them. So now the player state has include those header for both of them. Alt-Enter will to automatically do that for both of them. Alt-Enter will include those header files. So now the player state has these pointers and is setting them. But still, on Aura character, these pointers will be null, right? Because Aura player state has its own, and the base character class has its own pointers for these. So we're going to want to make sure that the Aura character ability system component and attribute set pointers are set, and we will make sure all is files. So now the player state has these pointers and is setting them. But still, on Aura character, these pointers will be null, right? Because Aura player state has its own, and the base character class has its own pointers for these. So we're going to want to make sure that the Aura character ability system component and attribute set pointers are set. And we will make sure that we do that. We'll keep in mind that that's something we still need to do. Okay, but we do know that the ability system component is constructed on both the enemy for Aura enemy and the player state for Aura player state. Now there's still some setup that needs to be done, and we're going to get to those things shortly, but before we do, we're going to do one last thing before wrapping this up, and that is to implement a specific interface that exists for the ability system. We're going to first implement that interface on Aura character base. Right here, just after a character, we're going to inherit publicly, we're going to say public I ability system interface. And Rider says, what's that? Well, Alt-Enter takes me to the build file and tells me I should put gameplay abilities here in public dependency module names, as we're attempting to access this from within our Aura games. And I should put Alt-Enter interface I ability system interface. And Rider says, what's that? Well, Alt-Enter takes me to the build file and tells me I should put gameplay abilities here in public dependency module names, as we're attempting to access this from within our Aura character base. Now, if we move this into the public array, we don't need this in the private. We don't need it in both places, so I'm going to go ahead and remove it from private dependency module names. We'll just keep it in the public. Now, here in Aura character base, Rider automatically included ability system interface. Now, what is this interface? Well, if I right click on it in Visual Studio, I could just peek definition, but here in Writer, I'm going to select go to, declaration, or usages to go to its header file. And we see here that it's just an interface that contains this pure virtual function, get ability system component. This interface is really useful because it allows us to simply check any actor to see if it has this interface, and then we can easily get its ability system component from it. Now, because it's a pure virtual function, it's mandatory that we override this. So I'm going to go ahead and highlight this line so that we can override it in Aura character base, as we now have to. So here in the public section, I'm going to override it. We'll say const override, and now we can generate a definition for it, and all I want to do in here is return that pointer. So we're going to say return ability system component. And that's it. Now, something I like to do when I create a getter for the ability system component is I also like to create a getter for the attribute set. It's just convenient. So along with this, I'm going to create a getter for the attribute set. So I'm going to say u attribute set, get attribute set, and this one can also be const, and I can just return attribute set here. Nothing really fancy needs to be done. I'm just going to keep it there. So iAbility system interface is now implemented in the character base class, and all it does is return those pointers. Now remember, if we're on Aura character and we call this, we could get a null pointer because we haven't ever set those pointers for Aura character. We only constructed it for Aura enemy, right? Now, I also like to implement this on the player state because I have the actual attribute set and ability system component on the player state. So we're going to implement that on the player state as well. We'll go to Aura player state, and we'll inherit from iAbility system interface. That's going to pop up that header. That interface is is now implemented in the character base class. And all it does is return those pointers. Now remember, if we're on it, it's ability system component from it. Now because it's a pure virtual to the public array, we don't need this in the private dependency module names. We'll just keep it in the public. Now here in our character base, writer auto for wrapping this up, and that is to implement a specific interface that exists for the ability system. We're going to first implement for Aura Enemy and a player state for Aura player state. Now there's still some setup that needs to be done, and we're going to get to those things shortly, but before we do, we're going to do one last thing before wrapping this up, and that is to implement a specific interface that exists for the ability system. We're going to first implement that interface on Aura character base right here. Just after a character, we're going to inherit publicly. We're going to say public ability system interface. And writer says, what's that? Well, Alt Enter takes me to the build file and tells me I should put gameplay abilities here in public dependency module names as we're attempting to access this from within our Aura character base. Now, if we move this into the public array, we don't need this in the private. We don't need it in both places. So I'm going to go ahead and remove it from private dependency module names. We'll just keep it in the public. Now, here in our character base, writer automatically included ability system interface. Now, what is this interface? Well, if I right click on it in Visual Studio, I could just peek definition, but here in writer, I'm going to select go to, declaration, or usages to go to its header file. And we see here that it's just an interface that contains this pure virtual function, get ability system component. This interface is really useful because it allows us to simply check any actor to see if it has this interface, and then we can easily get its ability system component from it. Now, because it's a pure virtual function, it's mandatory that we override this. So I'm going to go ahead and highlight this line so that we can override it in Aura character base, as we now have to. So here in the public section, I'm going to override it. We'll say const override, and now we can generate a definition for it. And all I want to do in here is return that pointer. So we're going to say return ability system component, and that's it. Now, something I like to do when I create a getter for the ability system component is I also like to create a getter for the attribute set. It's just convenient. So along with this, I'm going to create a getter for the attribute set. So I'm going to say u attribute set, get attribute set, and this one can also be const. And I can just return attribute set here. Nothing really fancy needs to be done. I'm just going to keep it there. So iAbility system interface is now implemented in the character base class, and all it does is return those pointers. Now remember, if we're on Aura character, and we call this, we could get a null pointer because we haven't ever set those pointers for Aura character. We only constructed it for Aura enemy, right? Now, I also like to implement this on the player state because I have the actual attribute set and ability system component on the player state. So we're going to implement that on the player state as well. We'll go to Aura player state and we'll inherit from iAbility system interface. That's going to pop up that header there. And we now have to override that function. I'm just going to steal the declaration for both of these getters from Aura character base, and I'll paste them here in the public section in our player state and go ahead and implement the ability system component here and just return the pointer. Return ability system component. So at least from the player state for Aura, we can always get it. So this is just one of those convenient things that we set up for characters or other classes that have ability system components and attributes as we generally implement the ability system interface. It's just one of those components attribute sets. We generally implement the ability system interface. It's just one of those boilerplate things that helps everything in the system interact with each other in a nice, convenient manner. So now that we have the ability system component and attribute set pointers, both on Aura player states and on the Aura character base, and we're actually constructing these objects. We're doing it in Aura enemy in the constructor, and we're doing it in Aura player state for the player controlled character. We're now ready to make that connection for the Aura character, because the Aura character has these pointers and they're null. The Aura player state has non-null pointers since we constructed them. Now attempting to compile, I see that Aura player state.h line 20 has an error because we're not forward declaring here. That is something we're going to want to do here as well. I'm going to copy those lines where we're forward declaring in the base character class. We're going to paste those in there. And let's just make sure we can compile before we continue. And we have a successful compile. Perfect. Okay, so in the next video, we're going to make sure that we tell the ability system component who its owner is. And we're also welcome back. We've now constructed our ability system component and attribute set. But I mentioned there was something related to replication. that we were going to do that still needs to be done related to component and attribute set. But I mentioned there was something related to replication that we were going to do that still needs to be done, and that needs to be done where we construct our ability system component. We've already set our ability system components to replicate. Here in Aura Enemy, I'll drag that over to the left, and here in Aura Player State, I'll drag that here as well. We see that we're setting ability system component to replicate for both of these classes. Now, the thing that also needs to be done is the following. I'm going to take ability system component and call the function set replication mode. Now, notice set replication mode takes an enum of type E gameplay effect replication mode. And notice that it has some comments here, but it gets cut off. That means the comment is a little bit longer than what we're seeing here. So what I'd like to do is browse to this function set replication mode. I'm going to right click and go to declaration or usages. In Visual Studio, you can peek or go to the definition. But here we see set replication mode. It's just setting a variable on the ability system component called replication mode to what we set it. But I'd like to actually browse now to E gameplay effect replication mode. Let's right click and go to that definition. That's going to open up ability system component.h. And here we see some comments. Let's see what it says. It says how gameplay effects will be replicated to clients. Now, I know we haven't learned about gameplay effects yet, so don't worry too much about this. We're going to keep this in mind for when we do start learning about gameplay effects. We'll circle back to this later, but let's just read what the three options do for us in this enum. We have minimal, and it says only replicate minimal gameplay effect info. Note, this does not work for owned ability system components. Use mixed instead. We'll talk about what owned ability system components means. Now we have mixed. It says only replicate minimal gameplay effect info to simulated proxies, but full info to owners and autonomous proxies. And then we have full, which says replicate full gameplay info to all. Now, what does this mean by minimal gameplay effect info and full gameplay info exactly? What does that really amount to? Well, here's exactly what it means. If we set replication mode to full, then gameplay effects will be replicated to all clients. So we have full replication for gameplay effects. When a gameplay effect happens, that gameplay effect will be replicated. Pretty simple. Now for mixed, gameplay effects are replicated to the owning client only. Now again, we haven't learned what gameplay effects are, but it's enough to know for now that they're used to change attribute values. We use gameplay effects to do things like cause damage or heal the player. And if that kind of change happens on the server, the client should know about it. If the character's health goes down, the client is going to want to show that in the HUD, maybe a health bar of some kind. Now for mixed, gameplay cues and gameplay tags are replicated to all clients. Now, those are a different story. And we haven't learned about those yet, but in Mixed, those are replicated to all clients. That will be significant to us once we learn what those things are. And for Minimal, we see that gameplay effects are not replicated. Gameplay cues and gameplay tags are. So gameplay effects, things that change our attributes, values, are going to have different replication behavior based on this replication mode. So the question is, which mode do we choose in which situation? And that's why this table here is useful, because, well, these are the rules of thumb here. Gameplay effects being replicated to all clients is not necessarily something that you're going to ever want. So you don't only really ever do that in single player where there's just one game playing. It's a single standalone game. But for multiplayer, player-controlled characters like Aura, we're going to want those gameplay effects replicated to the owning client. That's going to be us. If we are a client, then if an effect is applied to us on the server, we want to be notified of that. We want it to be replicated. So that we can update our HUD and respond accordingly on our client machine. And just remember, gameplay cues and gameplay tags are replicated as well. And then for Minimal, gameplay effects are not replicated. So this is good for AI-controlled characters, where a gameplay effect may happen on the server, but it doesn't necessarily mean that that gameplay effect should be replicated down to clients. However, gameplay cues and gameplay tags will still be replicated to all clients, even for a character whose ability system component is set to minimal replication mode. So we're going to follow these rules of thumb. We're going to set the ability system component on our player state for our player-controlled character to mixed. And we'll set the ability system component on the enemy, Aura enemy, to minimal, as it's a AI-controlled character. And we'll be programming this project for multiplayer. And the cool thing is, you can program a project for multiplayer, and it will still work in single player. The reverse is not true. You can't program a single player game and then just try to play it in multiplayer and expect anything to work. No, multiplayer has to be designed from the get-go, and that's what we're doing. So let's set the replication mode for our ability system components. Now, how do we do that? Well, the ability system component class has the set replication mode functions. So let's use that. And that will be your quest for this video. I want you to set the replication mode. I want you to do this using set replication mode and use the rules of thumb that we discussed. You're going to do this for the player-controlled character. You're going to do that in the player state constructor, and you're going to do this for the enemy character as well in the Aura enemy constructor. So pause the video and set the replication mode now. Okay, so I'm going to go ahead and close out of ability system component.h and CPP. And here in Aura player states, I know that this is for the player-controlled character. So I'm going to set this to eGameplay effect replication mode mixed. As per our rules of thumb. I'm going to copy this line and go into Aura enemy, and we'll set that here. And because this is the AI controlled character, we're going to use minimal for components. Excellent job, and I'll see you in the next video. Welcome back. So we're setting up our ability system components, and we set our replication mode. Now something should still be bothering you at this point, and that is that our Aura character base class has an ability system component pointer and an attribute set pointer. And it's only on Aura enemy that those pointers have been set with valid values. For Aura character, those pointers are uninitialized because we constructed the ability system component and attribute set on the player state instead for our player control character. These pointers have player. We construct character. Those pointers are uninitialized because we constructed the ability system component and attribute set on the player state instead for our player controlled character. These pointers have valid values for the player state, but not for the character. So I want that to keep bothering you, keep that in the back of your mind because it's something we do want to fix. Now, another thing we have to do is make sure that the ability system component itself knows who its owner is. Now, that could mean something different for our enemy versus our player-controlled character, right? Because for our enemy, the owner of the ability system component is clearly this enemy class. But for the character versus our player controlled character, right? Because for our enemy, the owner of the ability system component is clearly this enemy class. But for the character, that's not necessarily the case, is it? Because the player state is who actually constructs the ability system component. So how do we decide who's the owner of it? Let's talk about that. Now, the ability system component has this concept of ability actor info. That way, the ability system component can always know the actor info, such as who owns this ability system component. But the ability system component also understands the concept that it might be